welcome. I'm Katerina Skroumpelou, and the title of my talk is Web Maps, putting the M in Angular Web Apps, which is Web Maps, not Mangular, as some people say. So a little bit about myself. Like Simona said, I'm a front-end web developer at Upstream. I studied spatial analysis and spatial data visualization. I worked a lot with AngularJS and Maps APIs in my previous job, and now I'm trying to work with Angular and Maps. I live in Athens, Greece, and I code with my cat on my lap. So, what we're going to talk about today, we're going to see how easy it is to add a map to your Angular application. Then we'll see how you can add some data to your map and visualize it too. So yeah, that would be a map with some data on it. This is from the Google Maps straight away. And this is what we're going to do. We're going to add a heat map of some data. So we're going to talk about why you would need maps, talk about online map libraries and which one you should choose, how to integrate with Angular. You're going to see some code, some data visualization and examples, and then interactions with OpenLayers. So, why do you need maps? Well, I'm in love with maps, so I'll try to convince you. Maps are everywhere. I mean, think of any web app you're using. It's most likely that it will have an app either to show data on it. Think of Airbnb, think of dating apps, think of food apps. There is a map everywhere on the internet. Maps are used to show data. So they're useful to visualize your data on it, like your location or your users' locations. And maps are nice or interactive. How many times have you been on a web application and you've seen a map and you've zoomed in and out just to see where everything is? So, this is a non-exclusive list of some map libraries. You've got Mapbox, I think is one of the most famous ones. You've got Leaflet.js, OpenLayers, Google Maps JavaScript API, D3.js, the ArcGIS API, CartoDB, and now we're going to see what some of these are for and what some of these are not. Mapbox is a great library. Unfortunately, it does have pricing, so if you're not into pricing, you might not use it. Leaflet is free open source software. It's pretty simple to use, but because of its simplicity, it cannot handle very complex tasks or data visualizations that you may need. However, it's very widely used. OpenLayers is free open source, is very complex, and it can handle complexity. It's one of my favorites. Google Maps has some quota limits, but it can't handle complexity. You can make nice visualizations. And of course, you get access to the Google APIs, like the Google Places API, which is very, very useful. The D3.js is not actually a map library. It can handle spatial data visualizations. If you have spatial data, you can create maps with D3, but I'm just putting it there. ArcGIS, it's actually the ArcGIS, which you can create maps. It's enterprise software, it's powerful, but you may not need it for a simple map visualization. And CartoDB is also not really a map library, but it's great for visualizing spatial data. So, today's presentation is going to be about my two favorites, the Google Maps JavaScript API and the OpenLayers API. So, what about Angular integration in these libraries? These libraries rely on scripts that load them. So, we're going to talk about script loading techniques. Are we going to load them asynchronously, synchronously, or dynamically? So, the Maps APIs are loaded with a script. So what these scripts do, they actually define a global variable, a global object, that is the map and all its functions. So in the case of the Google Maps, it's google.map or OL for OpenLayers. So there are two ways to load a script, synchronously and asynchronously, as we all know. Asynchronously means that all JavaScript code will continue to load while the script is loading. And synchronously means that your page will stop everything and wait for the script to be loaded in order to continue. So what do we do from these two? Once the script is loaded and the global object is defined, normally you could be able to access your object anywhere in your JavaScript code like this. Like you could create a variable named map, and you could access the Google Maps global object and create your map. So you need to know when the script is loaded to use it. There are two ways to know that. First is you can load the script synchronously. But this has two characteristics, so the rest of your code waits for the script to be loaded. However, when it's executed, the global object is defined, so you can be sure that every JavaScript code that is below the loading of the script knows that the object is defined and can use it. Like you would load it like this from the Google Maps JavaScript API. However, this is not advisable since it can slow down your app a lot. And in the case the script is never loaded, well, then your app stops and half of it is never loaded too. The other way is you can load it asynchronously, obviously. In this case, you have to add a callback function, as shown in the example for the Google Maps JS API docs. You just add two attributes, async and defer, and you add a callback function that you see here. So this, when the script is loaded, it will search for a global function, in this case initmap, to execute it. And in the scope of this function, the Google Maps object, or the OpenLayers object in the OpenLayers case, will be available there. However, accessing a global function from the script loader is not so straightforward in Angular. Also, since we're usually targeting performance, you don't want to load your scripts at the beginning of your application. You just want to load it when it's actually needed, because you don't want to load things that are not needed until they're actually needed. Which leads us to dynamic script loading, or actually dynamic asynchronous script loading, which is actually loading on demand. So how to do this in Angular? You create a service that loads a script. I don't know if I can zoom in. I cannot zoom in, never mind. So you create a service. In this service, you create a function that will create a script element. It will add it in the head, and it will add an event listener. The load event listener for the script tag gives us exactly this functionality. It tells us when the script is loaded, and that when the script is loaded, a callback function is executed. That is passed as an argument to our function. So the event listener fires on script load. It calls the callback function, and that we pass to it. So in this case, say we are in our Angular component. We import the service to our Angular component, and then we use it. We use the load stream function from the service. We pass the maps URL, the ID of the script element, and then we can actually access the Google Maps global object. Notice how instead of referencing directly the Google Maps object, as we could and would be allowed when it would work, we are reading explicitly from the window object. We're doing this because otherwise the linter will complain, because it cannot see the definition of the Google Maps object anywhere else. So that's why we're doing it like this. So step by step again, we are creating a function. We are creating a service, the script load service. We are importing it as a provider to our app module. Then we defined it in the construction in the component we're actually going to use it with. Then we create a div in our HTML. The div, we add a template reference variable to it, the map element, so that we can access it from our Angular code, because it's a DOM element and we need to access it. We give height to the div, because empty divs usually have 0 height, and you actually have to define a specific height to it, not a percentage. So here, for example, we're giving it 90 viewport height. We select the div in our component with the viewchild selector, and then we place the map on the div. So we create the new map, and then we are adding this as a target to our map. So that would be the full component code, but okay, let's switch to some code to see it. Yeah, so you would import it. You would have your URL here, and you would load it like this, select it, and load the map. We're going to see it more afterwards. So show me the map already. Okay, so this is the map. I'm not cheating, this is an iframe, but it has an Angular application inside. So yeah, that would be the map. And this is Athens. Okay, so why are we using after viewing it and the viewChild decorator? This is a lifecycle hook of Angular, and we're using it because we need to access the component DOM view and its children. So ng after viewing it, which is the function that goes with the lifecycle hook of after viewing it, is called once after Angular initializes the component use and its child views and the view that the directive is in. So this lifecycle hook makes sure that our DOM is loaded, the view is loaded, the children are loaded, so that we can access DOM elements inside it that are already loaded and load their map on the element. So we use viewChild in the map element to let Angular know that we're looking for a native DOM element. This is the element reference. And then we hook it to ng after viewing it, where the view children have been created. So, what is a map if it's just a plain old map? It doesn't say very much, and you need spatial data on it. To just give you a small example of how important spatial data and maps is, well, in London in 1854, there was a cholera epidemic. So this physician, John Snow, wanted to find out why there was this cholera epidemic. So he went to Soho and he wrote down all the cholera cases around Soho, and he found clusters around a certain water pump. So this visualization of this spatial data found out that this water pump was contaminated. So spatial data came to the rescue, and the cholera case was ended because of this. However, you don't want to get too carried away with spatial data visualization. This is a funny post from XKCD. It says geographic profile maps, which are basically just population maps. It's just data visualization that visualizes actually, there are different cases, but they're actually showing where there is the most population in the United States. So they're not really very elaborating. So these are some spatial data representation formats. It's the GeoJSON format, the JSON format, the CSV, the shapefile, KML, GML, and there are many more. And each of them have different functions, and they're used at different cases, obviously. So where can you find spatial data? There are a lot of government services that provide the geographical data, and the European Statistical Service, and I've put some links on the slides. I will share with you the slides later. You can look them up if you want. So there are some different kinds of data and representations. You get points data, polygons, points with values, clusters, and according to the format of your data or the story that you want to tell with your data, you can create corresponding visuals. Again, there is a link here you can use afterwards. So for example, if you have points, we're going to see this map later, you can represent them with different shapes. So these are mobile phone masts in Camden in London. Or if you have different types of data, you can use different shapes. Or if you have different values for each point, you can use different radius sizes. So this just shows use of tube stations in London, for example, or you can use different colors. Or you can use polygons to represent polygon data. So in this case, these are just some words in Manchester, and the different colors show loneliness and social isolation factors. Or you can use polygons with colors, or you can use heat maps. So in this case, this is a heat map of letting bids in Camden. So it just shows where there is a cluster of more houses are wanted. So let's see how to do all this. So you get some, if you have polygons in GeoJSON, This is an example of a GeoJSON file. It just gives you some attributes. We're going to use, for example, the loneliness numbers to create a visual, and you get a geometry. So you have a polygon, and you have the polygon coordinates. The Google Maps JavaScript API provides a function that you can use to load a GeoJSON. So you can just add the file name of the GeoJSON and then add some style to it. So for example, here, we are adding data to our map, and we're setting styles to the map. So we're using its GeoJSON feature, as we saw before, to add some style to it. So from the feature, we're getting the property prevalence, which is the loneliness prevalence, and we are using it to actually color the map. And the result would be, okay, let's see the result here. So the result would be this. And, oops, sorry. So if you hover over each word, you can see down the prevalence factor of loneliness of those over the age of 65. So different colors represent different loneliness factors. The darker the color, the more the loneliness. Okay. So, okay, here we are. So you can have points. This is JSON data that have points. These are the coordinates, again, for London. Again, you're loading a JSON file. I'm just using an HTTP service here to load the file. And again, you're creating a new latitude, longitude object. You add the size to the shape you're going to represent your point with, and you add the marker, and you add it to the map. So again, the result would be, let's just put it on the map. I've commented it out too. Okay. So the result would be these masts here. Okay. Another type of data is CSV data. Again, you have points, and you can create a heat map with these. So again, you can add the heat map data with the heat map layer of Google Maps that provides it to you. Again, you add the data to it. You can add a custom gradient. That means the color that you're going to use for less and more counts of data. So the result again. Let's see the result. Let's remove the mask. So the result would be something like this, where the darker color means that there are more letting bids for houses, so houses are more needed in these areas around Camden. So, other methods that Google Maps provides is that you can change the map colors. You can add custom colors to the map. Now I've made this map look gloomy. It's gray and black, but you can use the traditional Google Maps styling. You can do this very easily. Google Maps gives you access to all types of features on it, like the landscape, points of interest. So you can color differently each type of feature on the map, the roads, the local roads, the highways. Another thing you can do is set focus buttons, like you saw. You can just click on a button and set a new center and a new zoom level, like we did with London and Manchester. So that was it about Google Maps. And let's see now about OpenLayers. So it's the same way to load the script and initialize it. And the OpenLayers, it needs more customization. So you have to define a tile server. So for example, you define the tile server as OpenStreetMaps. You have to define a view. in the center, the projection and the zoom. So yeah, these are some coordinates and the zoom level. And you can see the map. So yeah, if you want to see. So again, yes, the same way to do it. Let's go back. OpenLayers gives you the ability to rotate the map view as you wish. So if you were on the map, you can rotate it or adjust it to the view you want. Look how nice the Earth looks upside down. Okay. And you can also draw on the map. And it gives you a whole great library of drawing. You can draw points, or you can draw lines. And a great thing is that you can use the snap feature, and the drawing will just snap on the line, which is, if you've ever tried to use a design or an AutoCAD software, the snap feature is great. It just makes me excited. Okay. So you just can add or remove interactions from the map. As you saw me doing, you can stop an interaction mode, and now it's not drawing, or you can add an interaction mode and draw. And you can just save and export all the things you're drawing on the map on GeoJSON files that keep track of the coordinates and everything you are drawing. So it can really be helpful if you want to have some data that you know where they are on the map and just redraw them as a GeoJSON. Another thing you can do is, okay, the snap we saw. And another thing you can do, you can change the tiles. You can use Stamen tiles. There's a great site, Stamen, that can give you different types of tiles for maps. These are very stylish. I mean, if we zoom in a city, you will see how nice it looks. Yeah, it looks all architecty and designy, and you can use it. It makes everything look prettier, in my opinion. Or you can use the plain OpenStreetMap tiles. And so, that was about it. So what we learned about, we saw two map libraries, my favorite ones. We saw how to load them up, and I hope you will be able to load them up too in your Angular application from now on. We saw some data visualization techniques and how good it is to visualize your data and how useful it is, and how to interact with the map. So that was the end. This is just a photo of my summer vacations. I just wanted to add this because I'm really cold here, and I'm from Greece. These are my details. You can find my slides on this address. I will tweet it later also if you don't have time to copy it now. And this is the code from my presentation, so you can fork it or use it or do whatever you want. And follow me on Twitter, please, CyberCity. And please, please, please don't hate me. I know I'm horrible, but the slides will not work on Firefox because I'm using HTML imports. But I will try to make them work on Firefox in the future if you want. But from now on, it's just Google Chrome. I'm really sorry, and I'm horrible. So yeah, some credit and sources. I use some info from Joake's tutorial on view children and content children. And these are some data, where I took the data from. And this is my cat with some Angular things. So that's it. Thank you.